Hi, my name is Emma and I'm a physicist from Freely Accessible Remote Laboratories. During these Phi Labs experiments, you'll learn a lot about the applications, the use, and the discovery of radiation. You'll also get the opportunity to perform experiments with live radioactive sources through the remote control of experimental equipment hosted at La Trobe University. In this video, I'm going to explain to you what is alpha, beta, and gamma radiation. To understand radiation, we're briefly going to revise what is an atom. Atoms are the building blocks of matter. They are comprised of positively charged protons, neutrally charged neutrons, and orbiting negatively charged electrons. The protons and neutrons are connected together by the strong force and are orbited by small negatively charged electrons. The notation for an atom includes subscripts and superscripts. The number of protons in the atom is the preceding subscript, whilst the total number of protons and neutrons is the preceding superscript. This notation will appear regularly throughout this video. Radiation is the process of releasing energy in some form or another. Radiation can be released in the form of light, heat, sound, or even matter. Alpha, beta, and gamma radiation all occur as a release of energy from an unstable atom. There are two main types of radiation: ionizing and non-ionizing radiation. Ionizing radiation is strong enough to ionize the atom. That is, ionizing radiation gives orbiting electrons enough energy to leave the orbit of the nucleus. Ionizing radiation reacts strongly with matter and is strong enough to break chemical bonds. Alpha, beta, and gamma radiation are all forms of ionizing radiation. Non-ionizing radiation is radiation that does not react strongly with matter and is not strong enough to ionize an atom. Non-ionizing radiation is used for many applications, including heating food in a microwave, communication through radio waves, and is how the human eye is able to see visible light. Alpha radiation occurs when an unstable atom releases a particle to reduce its atomic number to find a more stable form. The alpha particle is comprised of 2 protons and 2 neutrons, like a helium ion without the electrons. The alpha particle is large and heavy and moves very slowly. It is a highly reactive particle and therefore cannot travel deep through matter. The typical range of an alpha particle is 3 centimeters in air before the air particles attenuate the radiation. For human skin, an alpha particle can travel about 0.04 millimeters deep. Beta radiation occurs when an unstable atom ejects a beta particle due to a high ratio of protons to neutrons. There are 2 types of beta particles: a beta minus particle, which is an electron, and a beta plus particle, which is a positron. A positron is a positively charged electron. Typically, beta particles are less reactive than alpha particles. Beta particles are small, high-speed particles that travel deep through matter. A beta particle can travel 3 meters in air and penetrate up to 5 millimeters into human skin. Gamma decay occurs when an unstable atom releases electromagnetic radiation in the form of light. Typical a gamma ray is a high-energy X-ray photon. Photons are packets of light energy that have no mass and travel very fast. Gamma rays are highly reactive and can travel right through matter. Gamma rays will penetrate the human body and still be detected on the other side. In summary, alpha, beta, and gamma radiation are all forms of ionizing radiation, which means they react strongly with matter and are able to ionize atoms. Alpha radiation is made of 2 protons and 2 neutrons to form a large, heavy, slow-moving helium ion. Alpha radiation is highly reactive and therefore does not penetrate far through matter. Beta radiation is small, fast-moving electrons or positrons. Beta radiation is less reactive than alpha radiation, but however is more penetrative. Gamma radiation is a form of electromagnetic radiation. It is highly reactive X-rays. These X-rays can be described as high-energy, highly penetrative, massless photons, where photons are packets of light energy. I hope you enjoyed this video. If you haven't heard of Phi Labs, visit www.philabs.edu.au and look at the experiments you can access for free. Phi Labs hosts a range of radioactivity experiments that students and teachers can access and remote control from their web browser. These experiments are hosted at La Trobe University in Melbourne, Australia, and are aligned with the Australian curriculum. We invite and welcome international users to access Phylab's experiments as well. Thank you for listening.